All right, we're going to talk about reciprocal functions today. Reciprocal functions are a type of rational function, and it's where we're going to start graphing. So, a reciprocal function has an equation of the form f of x is 1 over a to the x, where a to the x is a linear function and it is not 0. So the gist of it is that it's a 1 divided by some linear function. So 1 over 2x minus 3, or 1 over x plus 4, or 1 over x, or 1 over 3x minus 11, something like that. It can't be x squared. That starts to be a whole new thing. For reciprocal functions, it is specifically the reciprocal of a linear function. So 1 divided by a linear function. That's all we really need to know. Okay, so here's some stats, or the fact sheet, if you will, about the graph of a reciprocal function. So the parent function is just 1 over x. Just like for a linear function, the parent function is just x. The type of graph, this type of shape is called a hyperbola. Okay, it's called a hyperbola. The domain and range is all non-zero real numbers. It has two asymptotes, a vertical asymptote, vertical because it's x equals, at x equals 0, and a horizontal asymptote at 0, meaning there are these two lines right here and right here that the graph is approaching but never actually getting to, and that's why the zeros are not in the domain and range. Right, so it is not defined at x equals 0. Why? If I plug in a 0 right here, we're dividing by 0. That's a no-no. Okay, it has no intercepts. It's never going to cross the x or y axis because the x and y axis are the asymptotes. Now, depending on what we change this linear function to be, we might end up with intercepts. We will still have two asymptotes. They just may not be the x and y axis anymore. Okay, so those are kind of the general stats. This is what a hyperbola looks like for the parent function 1 over x. As we make changes to what that denominator is, it might move the parabola around. Okay, the domain of a reciprocal function. So let's talk about this for a second. The domain of a reciprocal function is limited to values for which the function is defined, meaning we cannot use values that make the denominator 0. Okay, so for example, x plus 2 is our denominator, so it's not defined at x equals negative 2, because that would make the denominator equal to 0. So that is where the asymptote would be. X equals negative 2 is our vertical asymptote. In this one, x cannot be 5, right? So x can't equal 5. In this one, x can't equal 0, right? The top doesn't always have to be 1, but it is just going to be a number for reciprocal functions. For rational functions, it'll get more complicated. So here's an example question. Determine the value of x for which f of x is not defined. So all that's asking is, where does the denominator equal 0? So 2x plus 5 equals 0. 2x equals negative 5, so x is negative 5 over 2, or negative 2.5. That is the value at which this function is not defined. Okay, so then two more, determine the value where it's not defined. All we're doing, like we've talked about, is finding the value that makes this equal to 0, and that would be 1. Find the value that makes this equal to 0. So that might be a little bit more complicated, so just set it equal to 0 and solve it algebraically yourself. And you can see where the negative 2/3 comes from. Okay, that's how we find the domain. The domain would be all values except negative 2, all values except 5, all values except 0, all values except 1. These values are where that vertical asymptote will be. Okay, so looking at this one, identify the asymptotes, domain, and range of the function. So the function is 2 over x minus 3. So the asymptotes, meaning what can x not be? Let's start with that one, right? The x cannot be 3. The domain for x is all values, but x cannot be 3, right? That's where this asymptote is. Horizontal asymptote, what value can we not get? Well, no matter what I divide 2 by, I can divide 2 by 1, or 2 by 2, or 2 by 999. It's getting closer and closer and closer to 0, but I cannot make 2 equal to 0 by dividing it. So the y asymptote will still be 0. range for y is not going to be 0, right? Because it can't get there. So you knew it's coming. We're always talking about our general form with h and k's, and here's what it looks like. F of x is equal to a over x minus h plus k. H gives us our horizontal translation, meaning it's going to move it left and right. Just like it always has been, h is backwards, so we're moving to the right if h is positive, meaning if we have like x minus 3, then h equals 3. We're going 3 units to the right, even though it's a minus up there. Just like it was in quadratics, just like it was in absolute value, it's backwards. Okay. K is the vertical translation, up and down. If it's plus 3, then k is equal to 3, and we're going up 3 units. Okay. The vertical asymptote, this is going to be big. I'm going to highlight this. The vertical asymptote is at x equals h. The horizontal asymptote is at f of x equals k. So whatever this guy is, which is why in these previous examples we haven't had any. What are we adding back here? 0, right? So that's why our asymptote's been at 0. Okay. And then orientation and shape, that's A. If A is positive, it looks the way it has been. If x is negative, if A is negative, excuse me, then the graph is reflected across the x-axis, meaning we're just flopping it upside down, just like we always have. If A is bigger than 1, it's being stretched vertically. If it's between 0 and 1, it's compressed vertically. Notice we're saying absolute value of A, just because if A is negative, we're just reflecting it, but the same effects occur. So let's graph one. F of x is equal to 2 over x minus 4 plus 2. So we need to state our domain and range. So I'm going to write those down here so we don't forget. And we're going to need to find our asymptotes. So let's start with the asymptotes. This is k, this is h, and this is a, right? So k is my horizontal asymptote at 2. That's the value this can never actually get to. And that's because this portion can never equal 0, so we can never actually get to 2. 4 will be my vertical asymptote, because x cannot be 4, which means that domain x cannot equal 4, range y cannot equal 2. Okay, it's 2 times steeper. So normally, if we look back at our parent function, I didn't have grids, so we're just going to probably make a table. That's probably the easiest way to do this right now. I know that 4 doesn't exist, so how about 5? How about 3? And then maybe we'll start with those two. So at 5 minus 4 is 1. 2 divided by 1 is 2, and 2 plus 2 is 4. At 3 minus 4 is negative 1. 2 over negative 1 is negative 2, plus 2 is 0. So at 5, I'm at 4, and at 3, I'm at 0. Let's do maybe 2 and 6, just to see what those would be. So 2 minus 4 is negative 2. 2 over negative 2 is negative 1. Plus 2 is 1. So at 2, we're at 1. So you can see that this one's going to look something like this. I apologize for my bad graphing skills, right? And it's going to get closer and closer to those lines forever. At 6 minus 4 is 2. 2 over 2 is 1. 1 plus 2 is 3. We're going to be right here. So then this one's coming something like that. Again, my curves are terrible because I'm drawing on this tablet. I would imagine you'll be able to do slightly better. Okay, so that's all there is to it. You're on to the homework. Good luck. Rewatch this if you need any help, and feel free to reach out if you have questions. Have a great day.